Hello everyone. In this video we will learn about AGP, its nth term and the sum of n terms. Before we go to learn about AGP, we must know what is the full form of AGP and what it is. In AGP, the full form of it is Arithmetico Geometric Progression. Name is Arithmetico Geometric Progression. This is a combination of AP and GP, that is Arithmetic Progression and Geometric Progression. That is why the name is Arithmetico Geometric Progression. Then what it is? Actually, any of the sequence which we obtain by multiplying the corresponding terms of an AP and a GP, that is an AGP. So we can say a sequence obtained by multiplying the corresponding terms of an AP and a GP is an AGP. See, suppose we have an AP, that is A plus D, A plus 2D and so on, A plus n minus 1 into D, the general term of AP. And GP is 1 R square and so on, R power n minus 1. Then the sequence by multiplying the corresponding terms, it will be A, this will be A plus D into R, this will be A plus 2D into R square and so on. When we get that is an AGP, is an AGP. What about the general term? General term of an AGP, that is nth term, can be obtained by multiplying the nth term of AP and the nth term of GP. We can see here the nth term of AP is A plus n minus 1 into D and the nth term of GP is R power n minus 1. So if we multiply this R power n minus 1, the general term comes as A plus n minus 1 into D into R power n minus 1. Now we will learn to find the sum to n terms of an AGP. Sum to n terms of an AGP, that is A plus D into R, A plus 2D into R square and so on. Suppose the sum of n terms is given by S. So it will be A plus D into R plus A plus 2D into R square and so on, A plus n minus 1 into D into R power n minus 1. If we multiply both the sides by R, multiplying both sides by R, we get here S into R equal to A into R plus A plus D into R square plus A plus 2D into R cube and so on. This will be A plus n minus 1 into D into R power n, or not? Subtracting these two equations, we will get S into 1 minus R, and this side, on the right side, we will have A plus. If we subtract this from here, A into R will cancel, so this will be dr. Here we find A plus 2D into R square and this is a plus d into r square. A plus d into r square will cancel and this will be dr square, and so on. We will be getting here dr power n minus 1 minus a plus n minus 1 into d into r power n. We want to find out the value of s. So can we say that s will be 1 upon 1 minus r into a plus, see here they are all n terms, and this is the extra term, this is n plus 1th term. If we separate this a, this will be a plus, and we take dr common from this, this will be 1 plus r square, so on. We will have n minus 1 terms in this or not, and here we will have minus a plus n minus 1 into d into r power n upon 1 minus r. We know this is AGP. So we know the formula for sum of n terms of AGP is a into 1 minus r per n upon 1 minus r for GP. If we apply that here, will we have here 1 upon 1 minus r into a plus 1 upon 1 minus r into what? First term is 1, that is dr, we can write dr here, into 1 into 1 minus r power n minus 1 because they are n minus 1 terms upon 1 minus r minus a plus n minus 1 into d into r power n upon 1 minus r. It means we are getting the sum of n terms is a upon 1 minus r plus dr into 1 minus r power n minus 1 upon 1 minus r whole square minus a plus n minus 1 into d into r to the power n upon 1 minus r. This is the formula to find out the sum of n terms of an AGP, or we can also use the complete algorithm to find out the sum to n terms of an AGP. We planned to discuss the sum to n terms of an AGP only in this video, but let's add to it the sum to infinite terms also. We already learnt in the video for GP that the sum of an infinite GP can be obtained only if the common ratio is less than 1, that is modulus r is less than 1. Same lies here also. If we have an AGP and we want to find out the sum of infinite terms, that can be obtained if mod r is less than 1. If we represent the sum to infinite terms by s infinity, will that be equal to a plus d into r plus a plus 2d into r square plus so on up to infinity? If we multiply r on both sides, multiplying r on both sides, we get here s infinity into r equal to a into r plus a plus d into r square plus a plus 2d into r power 3 and so on up to infinity. If we subtract them, subtracting, we will get here s infinity into 1 minus r equal to a plus a into r cancels, so it is dr, then dr square and so on up to infinite terms. Can we write this as a plus dr plus dr square plus so on infinite terms of GP? And we know sum of infinite terms of a GP is given by a upon 1 minus r. So here we can say it will be a plus dr upon 1 minus r. So we can say that sum of infinite terms will be given by a upon 1 minus r plus dr upon 1 minus r whole square. The same formula can be obtained From the sum to n terms also, if we write there that we know that r to the power n or r to the power n minus 1 is tending to 0 if n is tending to infinity when r is less than 1. Now we will discuss some of the examples to find the sum of n terms and sum of infinite terms of an AGP. There is an example, find the sum to n terms of AGP 1 plus 3x plus 5x square plus 7x cube. To find the solution of this, we write the given AGP, that is 1 plus 3x plus 5x square plus 7x cube and so on. We can see here the AP in this is 1, 3, 5, 7 and so on. And we can find out the nth term of this 1 plus n minus 1 into 2, because A is 1 and D is 2. And this comes as 2n minus 1. The GP here is 1x, x square, x cube. And for this GP, we are finding the common ratio is x. To find the sum, let the sum be given by S. That is 1 plus 3x plus 5x square plus so on, and the last term of this is 2n minus 1 into x power n minus 1. If we multiply on both the sides by r, that is x here, so we write multiplying by x, we are getting here s into x. This 1 will become x, 3x will become 3x square and so on, and this term will become 2n minus 1 into x power n. Subtracting these two equations, we are getting s into 1 minus x, because that is s minus sx, s is common. On the right side we are getting 1 plus 3x minus x is 2x. 5x square minus 3x square is 2x square and so on. We get here n terms minus 2n minus 1 into x power n. And we can see here this is 1 plus, if we take here 2x common, this will be 1 plus x square and so on. We will have n minus 1 terms in the GP. And here we have minus 2n minus 1 into x power n. We know the sum of n terms of GP. If we apply that here, this will be 1 plus 2x into 1 into 1 minus x to the power n minus 1 upon 1 minus x minus 2n minus 1 into x to the power n. Now if we find the sum, s will be 1 upon 1 minus x plus 2x into 1 minus x to the power n minus 1 upon 1 minus x square minus 2n minus 1 into x power n upon 1 minus x. This is the way we can find out the sum to n terms of AGP by using the algorithm. And now an example on finding the sum to infinite terms of an AGP, and that is here 2 upon 3 plus 5 upon 3 square plus 8 upon 3 cube and so on. To find its solution, we write the AGP first, that is 2 upon 3 plus 5 upon 3 square plus 8 upon 3 cube and so on. Here we find the AP is 2, 5, 8 and so on. The GP is 1 upon 3, 1 upon 3 square, 1 upon 3 cube and so on. The common ratio here is 1 upon 3. Let the sum of infinite terms be S, and that is 2 upon 3 plus 5 upon 3 square plus 8 upon 3 cube and so on up to infinity. Before we go to the next step, please subscribe the channel to get more videos on the concepts of mathematics. Now we multiply both the sides by r, that is 1 upon 3 here. So we write multiply by 1 upon 3. And we get here s into 1 upon 3 equal to, this will be 2 upon 3 square, this will be 5 upon 3 cube, and so on up to infinity. Subtracting the two equations, we get here subtracting minus, 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 and so on. On the left it will be s into 1 minus 1 upon 3. On the right it is 2 upon 3 plus 5 minus 2 is 3 upon 3 square. 8 minus 5 is 3 plus 3 upon 3 cube, and so on up to infinite. We are finding here 2 upon 3 is not the term which is in GP. So we separate it, plus we can see here this is 1 upon 3, this is 1 upon 3 square, and so on up to infinity. And we know the sum of infinite terms of a GP is a upon 1 minus r. Applying that here, we get 2 upon 3 plus 1 upon 3 upon 1 minus 1 upon 3. This is 2 upon 3 plus 1 upon 3 upon 2 upon 3, 3 cancel. So this comes as 2 upon 3 plus 1 upon 2, which comes as 7 upon 6 on simplification. So we are getting the sum of infinite terms as 7 upon 6 into 3 upon 2. This is 3, 2 is 6, so this comes as 7 upon 4. This is the sum to n terms of the given AGP. Like this we can find out the sum to n terms or sum to infinite terms of a given AGP. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.